going to go ahead and get started with this. And today we're looking at density. Now, with density, I want somebody to tell me, what is density? What's your definition for density? What does it mean to be dense?
The amount of molecules in the object.
What do you mean?
Like,
If we're talking about the amount of molecules being matter, isn't that really just mass? I'm asking a question. Oh, okay. All right, that's fine. That's fair. Okay. I think what you're talking about there is more mass than density. Well, it's not necessarily the amount of molecules. Now, what do you guys think? It's density. What does that mean? How many of you guys have heard of population density? I said that before in any of your previous courses. What is population density? Yes, China has population density, but only on the coast. Start getting into the actual interior of China, they're pretty much like living in Montana. You won't see anybody for months. So what is population density? Abby?
The number of people in a specific area.
Number of people. So number of people over some specific area. Square kilometers, square mile, square yards. Okay? I think in the United States, I don't know that statistic, never mind, I don't do that. One time I knew it. But it was something like in the United States, I think the average person, if you would actually take us all on, spread us all across the entire nation, we would have almost 100 square feet to ourselves per person. So we think about the cities and how densely packed the cities are. If you actually take everybody in the United States and spread them out, that includes babies and children, every person would have 10, basically a square is 10 by 10. So slightly dense, but not super dense. All right, so density. Basically, it's a ratio. That's the big thing. It's a ratio. So it's not just the number of molecules. It's a ratio. But it's a ratio of one thing to another. That's what it means to be dense. When we talk about density, it's not necessarily people per area. Scientifically, what we're talking about is the ratio of mass per unit volume. Ratio of mass per unit volume. Ratio meaning what mathematically? We think about how do we write ratios in math? All right, that's the basic middle school question. How do you write a ratio? There's 3 ways to write a ratio. I almost have math class. But this is where we start using the math that you guys learned in algebra and all your other courses. Okay. As a fraction. So density really is just a fraction. Well, it's a fraction of tau. So if we're going to represent this using a formula, density is a ratio meaning fraction. What goes on top, what goes on the bottom? There we go. It's the ratio of mass per unit volume. D equals M over V. That's it. What do I mean by unit volume? If I say 100 kilograms over 50 milliliters, is that a unit volume? What are the normal, the normal units for density? Especially in this class, what are our standard units for density? Grams for mass. What about volume? Grams per milliliter. Unit volume, 1 unit. So the mass over 1 milliliter, the mass per liter, the mass per cubic kilometer, or cubic centimeter. By the way, you might want to know, for those guys especially going to nursing, you might want to know that a cubic centimeter is the same thing as a milliliter, in case you didn't know that. That's really important that you know that. And how many of you guys heard of CCs? Especially those guys who are involved in sport vehicles, right? CCs are kind of important. Basically, all a CC is a milliliter. Okay, so it's cubic centimeters, same thing as a milliliter. All right, so that's density is mass over volume. So let's kind of try that out a little bit here. Let's say that I have a piece of material that has a mass of 154 grams, and I measure its volume, and let's say it has a volume of 62 milliliters. How do I find the density? So we know that density is mass over volume. Yeah, we said our mass is 154. Again, grams. What is our volume? 62 milliliters. Do a little bit of calculations on the calculator, and what do we get as our density? I'm looking for you guys to do that for me. 154 divided by 62. 2.5? Let's go a couple extra decimals on that. 2.48. I'm not going to be a stickler with sig figs. We're a little early to be teaching sig figs. So 2.48, 2 decimal places works great for me. Okay? Now, look at your units right here. That's where we get our units from. Grams divided by milliliters. Therefore, grams per milliliter. 2.48 grams for every milliliter. That's your density. Next question. Will that float? Who says yes? Okay. Who says no? All right, TJ, why do you say no? Don't know. Okay. All right. Alex, why do you say no?
It's like, I don't know how to explain it really.
Okay.
Like if it will float, it would
Tell me what happens when you put oil in water.
oil over the top.
Why does oil float on top of water?
So it's dense.
It's not. Let's get this clear. Density is not a measure of weight. Water is more dense than oil. What's the density of water? So one thing that everything's measured against. One. The density of water. So the density of H2O is 1 gram per milliliter. It's 1. Therefore, if you have a density higher than that, what are you going to do? You'll see. If you have a density less than that, the float. What if it's close to 1? Let's say I'm 1.3. Will it sink to the bottom? No. It'll be basically been out. Alright, there's not enough discrepancy between the two of them, so they'll kind of float in the middle. Yeah. It's kind of float in the middle. There's not a huge discrepancy between the two. But if I have, let's say, 1.9, that's enough for discrepancy that'll basically start falling down the bottom. So as long as they're somewhat close, you're going to have the same densities. They'll kind of float inside each other. Okay? Density is kind of important because it basically, when we look at the Earth, the entire formation of the Earth is completely based on density. When you go from the core to the exosphere, everything is based on density. That's how it all gets sorted out. That's how we know that our inner core is iron. It's one of the most dense metals that we have on our planet. It sinks to the middle. Anything that's lighter than that gets pushed to the outsides. why don't we have helium and hydrogen on our planet? Well, I shouldn't say we don't have it. Why don't we have it readily available in the atmosphere? What do we know about helium? When you put helium in a balloon, what does it do?
It lives.
Goes away. Well, the problem is we don't have a lot of hydrogen left in our atmosphere. We have a little bit of helium. But the problem is that we don't have a lot of those left over. Because in the formation over all these 4.5 billion years, please make sure you know that one. That's kind of important. 4.5 billion years. Basically, those elements have floated away. They're really, really light. They're not that dense, and they simply float out into the exosphere. Because of how light they are, because of how low their density is. So that's how we solve for density. Well, that's not what your homework is. That's just going to be a bunch of densities. Here's your mass, here's your balance line density. You have to be able to adapt to unfamiliar situations.